Hi everyone, it's Megan, back with another activity for you. This episode we will be demonstrating groundwater movement. Water that accumulates beneath the surface of the earth is called groundwater. Contrary to popular belief, groundwater does not form underground rivers, but is actually found in the small spaces and cracks between rocks and other materials such as sand and gravel. You might recall that from our first episode. Groundwater supplies about 38% of the water used for agriculture in the United States. The layer of earth, gravel, or porous stone that yields water is called an aquifer. If hazardous waste, chemicals, heavy metals, or oil collects on the surface of the ground, rain or runoff percolating in the soil can carry these harmful substances into the groundwater. Today we are going to demonstrate how water moves through different rock materials such as sand, gravel, and clay. You will need the following supplies. Before we start, let's think about how the water might move through these materials. We have gravel, sand, and clay. Which material do you think will allow water to pass through it the most quickly?
What's your hypothesis? Here are some things to consider. 1. How does the size of the particles that make up these materials differ? 2. Do you think the material particle size will impact how quickly the water passes through or infiltrates these three materials? 3. How does the amount of empty spaces, also known as porosity, differ between the three materials? And 4. Do you think that the porosity will impact how quickly the water infiltrates these three materials?
Now let's test your hypothesis. First, fill your first bottle or cup with about 3 inches of gravel. Then, set the cup with the holes on top of some kind of bottle or beaker to catch the water as it falls through. The sand might fall through some of the holes when you pour it into the next cup, but that's okay. It'll settle, and we'll discard the extra. For the last, we're going to fill it with clay. You can see that the sand has settled, so now we can discard what's left. Look closely at each container with the naked eye. Then take a look with your magnifying glass. Do you want to adjust your hypothesis after looking at the materials? To demonstrate how groundwater moves through underground rock formations and materials, pour about 100 to 200 milliliters of your colored water into each container. If you'd like, you can start the timer on your stopwatch to record how long it takes for water to travel to the bottom of each bottle. We're going to be pouring 200 mils. Pouring into the gravel first. Now the sand. And lastly, the clay. These are our results. You can see on our beakers, this is the 200 ml mark of the water that we poured. The gravel has all of the water already passed through. You can see there's definitely some still left in the sand. And the clay is taking the longest. Did you get similar results at home? Which container emptied the fastest? Which container emptied the slowest? How do you think these different materials influence water movement in a natural system? Join us next time as we demonstrate an activity about groundwater contamination. As always, feel free to contact us at the emails provided with any questions you may have. We'll see you next time.